All right, 6 minutes left for our stream to begin. I'm just monitoring the outage on Twitch. Just in case my stream just drops, just keep in mind that it's not my problem, my fault. It's just Twitch is going through some issues, but being a big company, sponsored by a big company like Amazon, I don't think so. They are going to go out of outage for a long time because they lose more money. So I'm pretty sure engineers are working. Hey there, Spam Bytes. If you actually know me from LinkedIn, just shoot me a message there so I can put faces to their uh, names. It's much easier for me. B9T5 Root. Hey there, dude. Saw you there on LinkedIn. Crazy Ass Coop. Nice to meet you too. Alrighty, it's working. Yes, sir, it is. Today's session is gonna be amazing because I am pumped to show you guys how to do buffer overflow. It's been on my mind since we started. Yesterday, it was day before yesterday, was supposed to be that buffer overflow, but I took some liberty to go to the basics of how to do certain command line tools off Linux. It's just a starter. The way I learned and how I learned it is because when you try to do something by yourself, like a self project, or you try to learn by yourself, you learn much more quicker than someone actually grilling the instructions in your brain. So I just tried to push people in that direction, and then if people go through it, it's much easier that way. So that's what I did, last session. If you did not attend it, it's already on YouTube. I post videos unedited directly on YouTube right after my live session, so people all across the world can watch the sessions on YouTube, pre-recorded. And I've been getting a lot of response. Thank you so much for giving so much support on LinkedIn and YouTube comments, private messages. You guys have been tremendously awesome. And honestly, to be honest, I did not actually think that I would pull this off because a lot of stigma going around that, okay, yeah, you need to be a professional to do professional level streaming, and that's not the case. If you think that you have at least working knowledge of certain things, stream it, let other people learn. The most I read this quote on some book or a couple of days ago, that the most quickest way to get rich is to by giving. That's financially, that's knowledge wise, that intellectually, that's just helping people a lot. The more people you help, the more satisfaction and gratefulness you get in your life, and that's what I've been trying to implement in my life since past couple of months. So this is me giving out to the people. I want to invest in you and invest in your building of your career in cybersecurity. Use me the way you want. Just ask me a ton of questions. I'm not one of those people who is gonna be on Twitch. You say, okay, I'll type the comments, and then whenever you text me in private message or meet me in real life, I'll be like, be gone from me. I'm not that type of person. I'm just the same. The way you see it on Twitch, live streaming, just the same in real life. Just send me a message on LinkedIn, however you want to reach me out, on Twitter as well, and I will respond to you within the next 5-6 minutes. I like to engage in my people, whoever I talk to, and I want to make sure that they are doing great, and their success is my success. So that's kind of person I am. So that being said, a lot of people have been requesting a simpler yet much more efficient way to do buffer overflow, not only for OSCP exam, but also for a lot of other Walnut Hub machines or Hack the Box machines, or you have Try Hack Me. I don't think so Try Hack Me has buffer overflow, but it's important to know how this particular type of vulnerability exists. It's different from your web vulnerabilities. It's different from every single other thing. It's mostly meant for assembly level language, more high level programming in Windows or Linux. Buffer overflow usually works in the RAM, and that's the only way you get past the buffer, and then you point it to the actual address where actual pointer should be pointed at, and that's where the writing is done for your exploit. We're going to do all that. I'm going to show you everything. I tried to do it on my iPad, but I don't know how to pull it up on the screen over here live. I really wish that Twitch has this feature where you can broadcast your iPad. You can make drawings and everything on it, like and then broadcast it alongside this frame which I'm doing, which is this monitor. So, but fortunately, they don't have that feature, which kind of limits me. But Qualcomm, I think they have their, not Qualcomm, Wacom, their writing pads. They have it. You can actually do it live, and I think Network Chuck does that really well. And I'm kind of imitating that, but I'm failing every single time I turn on my iPad and then try to connect it to Twitch, and it just doesn't work. So I'm gonna try my best. Is the buffer overflow attack on memory the same as buffer overflow on web page? Sort of, kind of. I know on memory it's much more deep level on the RAM, but I'm not sure of how the buffer overflow works on web pages. If you do know it, just send me a link. I'll take a look into it. But I gotta Google that. I've never tried it on web pages, but so if you know it, kudos. Share it with the people. Let's see here. Oh, it's 4 o'clock. It's time to dig in. So for the sake of this session, I have already downloaded the buffer overflow OneHub machines. You can go ahead and download it from this website, onehub.com. This was bought by Offensive Security not too long ago, like a couple of months ago, and they maintain all the machines in it, which is really good because a lot of these machines are need to be vetted before they send it out to public, and this is the most easiest way to get a virus or malware on your system. So it's much better that Offensive Security is taking a part in maintaining and vetting these machines. Buffer overflow, the brain pan, there are 3 of them. All 3 of them are related to buffer overflow. We're gonna do number 1, most easiest, but it builds the foundation on how you should be doing it. And I recommend you start with number 1 and then progress to number 3. We're just gonna do number 1. Moving forward, you can do number 2 and number 3 by yourself. Once you're comfortable with that, you can attack much more difficult machines. But by the time you're doing number 2, you're way too qualified for any of the exam level buffer overflows, whichever you get in, EJPT or JPT or PTX, whichever eLearn Security has their own thing going on with acronyms. So you should be very well versed once you finish number 1, at least number 1. Try to do this. So once you go over here, you can download it through the mirror and verify it using the, I think they give the hashes somewhere. They used to give that hashes before. Oh yeah, there is the MD5 hash and the SHA-1 hash. But you just download it. Don't look at these walkthroughs. These are, as you can see, is fairly old. Most of the things are the same, but the Msf Venom exploit code is not the same because Msf encode was the encoding which was utilized for encoding your exploit to work on Linux systems, but Metasploit actually removed that from their system, so you cannot use Msf encode, but it uses Shikata-Ganai encoding for your exploit to be developed. If you don't know what I'm talking about, don't pay attention to it at the moment, but keep in mind that we're gonna touch base that moving forward. Come on, don't go out on me like this. And I messed it up. There we go. So just download this virtual machine. I'm gonna check a pawn to own guy did it to get out of the VM. Oh, that's pretty cool, dude. Yeah, if you're talking about the VMware exploit in which you get out of the virtual environment to the actual host environment, that might be what I'm thinking what you're talking about, but I'm very well aware of that exploit which is in the wind. VMware, I think, fixed it in the vSphere client, but I need to look into how the POC worked. This is a problem with most of these exploit developers or people who actually post the exploit, that they don't give a POC, which kind of pisses me off because if you say that you found an exploit in certain things, just let out a POC, dude. How hard it is to let the whole world know that you found it and here's the working exploit. But they somehow want to give it to the companies for letting them fix it. But and they take their own sweet time on fixing it until they get a breach, and then they call the FBI, and then everybody is in problem that, oh yeah, we should have fixed it, but we took our time, just like SolarWinds did 6 whole months to detect an exploit. That's just bad SOC. That's all it is. If it takes you 6 months to figure out in your own cybersecurity company that there's an exploit running, and everybody has backdoor access to it, yeah, you need to reevaluate your priorities as a SOC. The CISO should be resigning. You should be hiring a new CISO, but I guess that's how it works in corporate America. I think this outage is pretty much gone. The broadcasting is partial outage. I'm just going to close this out and then pray that it doesn't break on me. So that being said, let's just jump in. I want to show you that the moment you run your OneHub machines, I'll show you this. This is the BrainPan system. Virtual machine, as you can see, I don't know anything in it. And it's gonna give me a wrong password, access denied. There we go, login incorrect. So this needs to be running. This has its own IP address. You won't be knowing the IP address straight off the bat of these virtual machines, which you download from OneHub, but there's a quick and easy way to figure it out. I'm gonna show you that. Make sure that you are connecting the network adapter on a NAT. With the NAT, what it does is your computer assigns a virtual IP address to these virtual machines, so it's not copying the same IP address which your computer has, which is connecting to the actual internet. So it's a virtual net IP address, which is important because whenever I'm doing live stream like this, it's important that I hide my IP address. I try to hide it, but then every single time I finish a session, I actually go ahead and reset the IP for my entire computer in the system. So I renew the lease and it just changes the IP address. It's just to protect myself, but if you're using NAT, it's much easier because a lot of virtual machines, whenever you're working in NAT, they talk to each other instead of connecting to the actual internet. So it's helpful. I have my Kali machine on a NAT, I have my BrainPan machine on a NAT, and I have my Windows 10 machine, which I had to download. Freaking 10 gigabytes of this file I had to download yesterday to make sure that this immunity debugger works, and everything is connected via NAT. Second of all, if you want to use, if you don't want to use the virtual machine of Windows, you can always use Wine. Wine, I don't know if I have it installed. Yeah, Wine is installed. So with Wine, it allows you to execute Windows exe files on Linux machines. So very helpful, but it somehow doesn't work in my Linux system. So I tried it a lot yesterday, but it failed a lot. So anyways, I'm gonna go ahead and go to my usual routine of OSCP syllabus. That's what the agenda is for this session, and pretty much every single session until we finish the entire syllabus to go through it. So I'm gonna cover all that later, but I'm gonna jump into buffer overflow. Yep, module number 10 is buffer overflow. It's quite huge and quite intimidating, but it's an easy 25 points on your OSCP exam. I'm not going to discuss any of these, however they are going, but I have my own steps which I have created, and I can share you the template in my YouTube links. I'll put it in the description, a template which you can actually build the entire buffer overflow code step by step by yourself. I'm going to do it here, but you can do it by yourself the way you like it. And you can basically follow that template wherever you want, and then it's going to give you root access, or at least lower level access, which you can privilege escalate later. So I'm going to explain all of these, but I'm going to jump into my, I want to actually use Obsidian for this. This is a new notes thingy which I found. Hang on. So I don't know how this is, but someone recommended to me to use this, so I'm gonna go ahead and use it and then see how it is. So today's buffer overflow session is going to be only in Obsidian instead of Notion, but I'm gonna send you a Notion link for downloading the template right after this. So jumping into buffer overflow, first of all, you want to know your IP address. This is pretty important because there will be 3 IP addresses we'll be playing around with, and it's important to know which one is which. I call it step 0, and we're gonna go in step-by-step basis. We're not gonna jump anything. So I have my Kali IP address, which I can find it over here. ifconfig, and which is should be 172. Damn it, can't see nothing. Oh, there we go. 0.8. That's my subnet. I have my BrainPan IP, which I don't know. You can do net discover, and it's gonna scan the entire subnet of 0 to 24. This works sometimes, but it fails most of the time. But it's important that you use net discover whenever you just have access to a Kali machine on a pen test. I use this handy little tool, Angry IP Scanner. It just helps me. I'm kind of lazy like that. Let's say you got to use your tools, man. If you don't use your tools, they are no good to you. I'm gonna put 0, and then I'm gonna do 255. That's the IP range. I'm gonna wait until it discovers. One is just accidental network manager which I created. It should not be, but it failed kind of. 8 is the Kali machine, which is working. You can see that Apache is active. That is port 80, which we did last session. So that's why it's still showing up. And then, as you can see, the ping worked in the 0.9 IP address, which is my BrainPan. And in order to confirm that, but first I'm gonna go ahead and write this down so that I don't forget it, and then I can close Angry IP Scanner. 2.16.229.9. Once that is done, close Angry IP. Now I know that it's 229.9, so I'm gonna go ahead and run an nmap scan. SV 172.16.229.9, and wait until the nmap is over. With nmap you get to know what that machine is, what ports are open. This way it's much more easier to figure out that if you're in the correct machine. I'm gonna go ahead and increase this thing. Anyways, not showing up. This is better. Come on. We are supposed to find 2 ports, port 9999 and port 10,000. These 2 ports will allow you to access the machine and download that executable. Buffer overflow is basically using the executable and then finding if it is exploitable. If you have any Linux application, or if you have a Windows application, you can go ahead and use buffer overflow to figure out if it is easy to hack through the RAM and utilize the buffer in it. It's very hard to do it. Most people don't attempt that. But if you know how to do it and you know assembly language, it's darn easy. And for this, you don't need to know assembly language. You just need to know basics, which we're gonna cover, and then we should be fine. So anyways, port 9999 is Abyss. The service running is Abyss. I don't know what that is, and I'm not gonna Google it at the moment, but I know for sure that this is a BrainPan machine. Enter the password is asking me for that. That means that if I connect to port 9999 via NCAT or netcat, which I showed you yesterday, or the day before yesterday, then you should be seeing this page, which is BrainPan. You also know, based on a previous session, that simple HTTP server is a Python HTTP server which hosts a file on that server. So if I connect to simple HTTP server on port 10,000 in my browser, I should be able to download the exe file or whatever is hosting on that file. So let's see. I'm just gonna mute my phone real quick. Getting a ton of LinkedIn messages from you guys. So anyways, I'm gonna minimize this in the back. So these two ports are open. Let me just go to a browser. Yeah. If I do 172.16.229.8, oh sorry, it's 9, and then it's 10,000, and if I hit enter, I should be seeing that it's working, that port is working. But if I don't know which location to go in this, so what I'm gonna do is I'm gonna run a Dirbuster. With Dirbuster, you can figure out if so. Here's a quick tip: whenever you see a website, whenever you can access a page which is on a website and something comes up, the most quickest way to figure out what directories are available is do a Dirbuster. At this stage of my pen testing career, I don't even think twice. Whenever I see port 80, port 8080, anything related to a browser open, I just jump into Dirbuster because I know that it's gonna actually reflect me the directories. So just keep that in mind whenever you are jumping into pen testing and you actually find port 80. That's the first thing you need to do. Port 80 is, you see blood in the water, you jump and then go attack it. 229.9, gotta do 10,000 here. Select my word list, which is in user share word list and then medium word list. So user share, I type WO and then it comes up Dirbuster, and you have a bunch of it available over here, but I use Dirbuster and the medium one. The small one and the rest of them are useful, but the medium one does the trick from a lot of hack the boxes as well as a lot of other machines too. So I'll keep the rest of the same. I don't need too much in it. Running it, and then selecting a second tab over here. Whenever you see a slash, a forward slash, that just means that it's the main index.html. That page exists. If you see a response 200, that means that you can access it. There is a file size in it as well. Sorry, the size. So that means that there is content in it, which I can see over here. Now, second directory which I found is a bin. That just means that this is a Linux machine. Linux machine actually, and bin proves that it's a Linux. And second of all, I know that it's a Linux because whenever you see in the moving forward sessions of today that we will be attacking a Linux system, BrainPan is a Linux machine. I need to first stop this because I know that it's just bin over here. You can let it run. I usually let it run and then I'm doing more reconnaissance, but you right click on it, open in browser, opens up the entire thing. This is the BrainPan exe. I want this in my Windows machine. So what I'm gonna do is I'm gonna go ahead and go to a browser in my Windows machine and then type 172.16.229.9/1000. Sorry. Exe, I download this, wait for it to finish, should be pretty quick. Once this is done, you can go ahead and bring this to your desktop because we will be running this like literally 50 times in this whole session as an admin. That and Immunity Debugger. You also need to install Immunity Debugger, so just go to its website, just Google it. You can use Immunity, you can use Ghidra, you can also check for alternatives. This is what I like to do if I'm not willing to pay for stuff. x64dbg is for Linux. It's very useful. And then there is Ghidra. This is an open source project by NSA. They launched it, and then they figured they use this application for everything, for buffer overflow work. And IDA Pro is, I think there's a free version, but there is actually a paid version as well for IDA Pro. People call it Hydra, but Ghidra is free of cost. This is paid, yeah, you can see it, but it's good for Mac, Windows, and Linux. Works in everywhere. If you got the money to shell out this and you're really good at reverse engineering, use Hydra Pro. Forget about anything else. So install your Immunity. Once you're done with it, it should look like this. It's gonna also install Python 2.7 because Immunity is kind of old like that. It still uses Python 2.7. Everybody in the world is using 3. Anyways, what I want to do is, first of all, I'm gonna go ahead and document. My Windows is 172.16.229.11. I know this because I can go open this ipconfig.11. I write down all of these on my machine, on my notes over here. I do step 1 and then jump into setting up all the stuff required for it. I don't need these two. I surely don't need the Derbuster. All I need in Linux is my terminal and mousepad, which I'm going to show you later because I need to edit some scripts. I don't need this either. Close that. Now the beauty of the NAT system which I set up earlier of keeping all these machines on their own network is that whenever I'm sending a command to these machines to execute the exploit, it's gonna work because these are all connected. That's the benefit of it. So first of all, you're gonna run Immunity as an admin. It's gonna load up. You'll see a lot of gibberish. Don't think too much about it. Don't be intimidated about it. It's just how it is. Immunity Debugger is working to make sure that you can understand really high-level programming languages as well as low-level in the system. So once I run BrainPan as an admin, it's gonna bind to the port 9999. Now, if you attended my previous session, you would know what bind shell as well as reverse shell is, as well as bind port and reverse port is. So in bind shelling, what we are doing is that if, say, Bob and Alice are in 2 different places of the world and they are not connected via VPN, what Alice can do is that Alice can attach a terminal or any application to the port, let's say 45,000. She can attach the cmd.exe or bin bash to the port 45,000, and then Bob, what can do is he can connect to that internal IP port 45,000 or external IP port 45,000, and then he'll be directly presented with that exact cmd.exe or whatever program Alice has set it up. Very useful if you're using intranet to communicate, but don't want to give your VPN connection to some outside rando, because that's dangerous. Helpful for contractors. A lot of people do this whenever they're doing contract work, contract pen testing. So it's binded to this. I want to make sure that I'm attaching to my Immunity so I can do more work on it. So I click on File, I click on Attach, I select BrainPan, which is the PID of 6368. You can see the name over here, and I'll hit Attach. Now you'll see a lot of gibberish. This is pretty common. This is how the entire thing is loaded up. What you need to pay attention is this on the left side. I don't think so you can see it. This paused screen over here, that is your more important part. If you want to run an exploit on buffer overflow, first thing which we're gonna do is hit this play button. Once you hit the play button, it starts running and it's gonna start compiling code whichever comes through. So that means that you have attached the program to Immunity, and Immunity is once you run it, the program is gonna run in its own container. I'm gonna expand this. It's because of this my frame over here, it's not showing you correctly, and I kind of wanted you to see this. Hang on a second. Let me see if I can change this over here. Come on, there we go. Okay, now you can see that it's running. I can also see your chats, so that's pretty cool. Um, so we are done. Immunity is set. Windows is set. Now I need to start coding. For simplicity of the code, I have created a small Python code, which are with my basic Python knowledge. Keep in mind that you don't need to be a Python ninja to do pen testing. You don't need to be a ninja in coding. If you wanted to be a coder, you would be a software engineer. But it's helpful to be a coder as well, because you need to know how to build your own scripts. But 99% of the pen testers, they usually are code readers. They can read the code so well that it's much more harder for any actual software developers to figure out what the actual problem was. But if you give it to a pen tester, they can use the source code and read it out to figure out what it's actually going to do. So if you don't want to learn actual coding, which is an entire 5-6 years of your life wasted, you can just learn to read code. That's what I did in my entire degree. I learned to read code for the first 2 years of my college. I read everything. I read C programs. I read assembly level programs. I read Python. Go was pretty new at that time, so I learned that as well. But I only read it. And if I see a code, I know what it's executing and what the steps are, what the outcome is going to be. That is much more important than actually writing the code, because even software developers, they just copy paste it from Slack Overflow, and some of them actually develop it, but majority population, you just copy paste it. It's freely available. Some smart guy will be actually writing it. So I have developed this small Python code. I'm going to walk you through it. I've written a bunch of my own flair so that it can just, you know, humor. So this is important in the beginning. Hashtag exclamation user bin Python. It's gonna go to this user bin and then the Python folder, and then extract actual Python code and execute it. Whenever you're writing Python code, you need to put this in the beginning. Import socket. Whenever I'm putting socket, that just means that I am using the network connection, TCP/IP connection protocols. That's inbuilt. So whenever I'm doing import, that means I'm importing from the actual libraries of Python. Libraries are basic stuff, building blocks of Python. There's tons of library. You can import math and do actual complex math. You can import like freaking AI and then do AI stuff with it, because Python supports artificial intelligence. Fun fact, the entire Google AI is built on Python and stuff like that, so it's pretty easy if you know how to do AI. Second of all, that's my socket, which will utilize the TCP/IP repositories, libraries. Then I put in the target IP. This is the variable. This is the actual value of it. This is another variable called port. This is an actual value of it. And let me check. Brain pan is okay. Yeah, perfect. We are fine. Variable value, variable, but it has actual value, which I'm going to show you. So if you know a little bit of hexadecimal, it's helpful to know that x /x41 is basically the value for a, capital A. I can, if I don't want to utilize this, I can actually put this, and then it's gonna print a multiplied by 1000. So it's gonna print 1000 A's. In a usual buffer, imagine a buffer to be a rectangle rectangle, and then there is buffer in between it. What you want to do is fill the buffer enough that you reach the actual EIP pointer. I'm going to show you how to do that as well. With the EIP pointer, what it does is it's actually putting that exploit in. If you craft an exploit in the EIP pointer and you figure out where the EIP pointer is, it can actually craft it and run that exploit on the program level. So once you control the EIP, you control the entire thing. You get root access or user level access on the entire application. So I'm using 1000 bytes of these A's to fill up the buffer And I don't know where it's gonna land for the EIP, but that's the discovery part. The entire buffer overflow is finding the EIP and then creating your own exploit to run on the EIP register. That's basic buffer overflow. Everybody should know this. It's just controlling EIP. If someone tells you otherwise, they need to really reevaluate what buffer overflow is. Buffer is a variable. That is because I have created buffer over here. Shouldn't have done that. Anyways, the reason I put buffer over here and then junk right over here is because I'm going to build up on my variable list in the future code, which I'm going to show you. So try except is a type of conditions where it's going to try this piece of code. If it doesn't work out, it's going to run this code. That's basically what it is. Try except is just conditions, just like you have for and you have while loop and you have a bunch of loops going on. The for and while loop are the most famous ones, but try except is like conditions, like if and else or else if this works, if it doesn't work, else use this. So if and else, simple English. They try to use English, regular English in Python coding, pretty easy. Print this, just gibberish. You can just type whatever you want. I just don't hold on to your pants because it's working. What this does, whenever you are using socket, a library, you need to make sure that you're actually using this line. This basically connects to the socket stream on TCP/IP connections, so it's helpful. And whenever you're doing connect, this is a new variable, connect equals s.connect, that is socket.connect, target IP and my port. So whenever you are in your RAM and you define two variables, that comes after your, I think, your EBP register. So these two ports, these two variables, which we already defined earlier, we're just utilizing right now, so we don't have to type IP address and port like 50 times. This is just receive and receive. This is just send the buffer through that IP stream. Once it's done, just type done, bro. And if it doesn't work, I give you an embarrassing crash report, so you feel a little bit bad about yourself. So once that is done, I am going to go ahead and save that. And this is my step one. So I'm just going to go ahead and bring it to my step one folder, where it is over here. I'm gonna with my template of my Notion template for buffer overflow, I'm gonna actually print this exploit code step by step, which I'm showing you guys, so you don't have to develop your own. You can just modify my own and then use it for your purpose. But I'm gonna step one, develop an exploit. Okay, step one is done, and let's see here, and run it. Minimize that. How do you run it? So in order to give execution rights to your Python, if you have attended my previous session, we know that chmod does that. Plus X for execution, and then step one. Oh, I know why, because I'm not in my directory. It's in my desktop. In order to get this, I'm just pressing tab. Whenever I'm pressing tab, it actually cycles through the entire, all the steps, whatever program is there with the same keyword. So I need step one, press enter, and that gives execution rights. In order to check that, ls.la-la, it gives, so you can see that it's tag X, which just means you're given global execution permission. Okay, once that is done, clear that out. In order to run it, I'm going to use Python step one, Python py. Now, a few things are going to happen when I run this. I need to make sure, first of all, that I am displaying this correctly. If this runs successfully, what it's going to do is actually going to print 1000 A's in the buffer. and you're gonna see that very clearly right over here. That's why I pulled it up, the brainpan.exe, because it's waiting for your connection on port 9999. If you see our code, it's actually connecting to port 9999 on this IP address. This is my Windows IP address, just to let you know, because you are running okay. I'm trying to dumb it down more so that I remember it for my sake. I know you guys are pretty smart, so just because if you're running your brainpan.exe as a vine on your Linux machine, you need to type your Linux IP address, which is your actual IP address of your Linux machine, which is, in my case, it's 0.8 instead of 11. But since it's on Windows, I'm going to run that. Those are two things which is going to happen. I'm going to save that real quick. And second of all, this program which is running on Immunity Debugger on the left side over here, on the right side, you're going to see that it's going to pause. Whenever it pauses, it means that it's crashed. In order to verify that, on the left side you will see that access violation occurred, and it's going to tell you what was the access violation. In our case, it's going to be x41, 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 yada yada yada. It's going to show you 4 times. The length of the Eip register is 4 bytes, I think so, because that's why it overrides 4 times. So let's just see if it works. Fingers crossed. Hold on to your pants. A little bit of jokes over there. And if it works, let's see if it works. Come on. Restart. Play. Okay, somehow it worked. That's because I did a restart. Let me see. Should not be because of this. It'll be a disaster if it's because of this. Okay, it worked. I don't know why. I think, oh yeah, I know why, because I actually set it up with Python step this and then actually saved it later on, so it didn't work properly. Anyways, like I was showing you before, it's gonna override the entire RAM with Ace. It's gonna show me how many bytes of the buffer has been overflowed by 3, as well as it's gonna, like I showed you earlier, it's gonna show as paused on the right side, bottom right side, and access violation while executing 41414141, which is AAAA, which is what you put in as an exploit code payload. You can see that entire buffer has been overflowed with just A's. And here, which is much more important part, I want to see if I can increase the font size. There we go. Much more human readable. The Eip register is your pointer register, which you need to control. As you can see over here, it's now overflowed with just A's. I don't know what's the actual location, but I'm going to figure it out. EBP, ESP are different registers. There is an entire course on YouTube by, I think, Live Overflow, who they discuss a little bit about assembly language code and registers. And it's kind of important that you go through that only if you're comfortable with buffer overflow. Then only you will appreciate what registers are, and you'll understand what registers do if you understand buffer overflow. We know we need to control only Eip. That's our motto. That's what we're gonna do. Rest of the stuff you don't understand, don't worry about it. One quick thing which I learned while I was doing this is that if you want to restart this, you can always close this out. Right click on BrainPan, open this as an admin, open your Immunity Debugger as admin, and then play again. or you can just hit this restart key, which is on the left side of your X, which is terminate. Just hit restart, press enter for confirming yes, and then press play again. It's going to actually do the exact same thing, but it's going to reverse that. It's like a snapshot which it creates whenever you're opening everything. You see jump is on brainpan, and that means that my brainpan.exe has been working, and we are back to normal state. I'm going to set it as running, so that next code which I write is just going to work that way. So what did we learn? We learned that we can control the EIP, and our program brainpan.exe is exploitable. That's all we learned in step 1. That Brian.pan.exe is exploitable. Now it's exploitable. Now everybody knows this. Now how do you actually exploit it to certain things where you want it to go through? If you have, I'm so glad I found you. Value Iron, thanks a lot, man. Thanks for sharing your knowledge with us. You're welcome. You're welcome. See, I just want to invest in you guys. I rarely want to make sure that I'm getting out of this anything. All I'm learning is that I am revising my knowledge, but I want to make sure that I invest more time in you, or more resources on you guys. So just ask me any questions regarding to this. Just an open book. Interrupt me anytime. If you don't know how this works, we can actually discover how to fix this by ourselves. So now the second step is we know that exploit works. So now the step 2 is finding an offset. Now finding an offset just means that you want to find that exact value where it overrides the EIP register. In our session, you could have seen, I changed it, but you could have seen 41, 41, 41, 41 in your EIP register over here. That was because it was all A's. I need to know what's the exact offset value. Now there is a way, there's a Ruby gem which you can use from Metasploit. It's in your Kali machine. You can use that to find the the offset values, but there's a much more easier way I found, and I used it in my exams as well, so it works. If you go to if you Google wire mask buffer overflow, literally the life-saving tool. Now what this does, it's going to create a pattern, a unique pattern of unique words. All of them are different from each other, and when you input this instead of your gibberish A's, this is going to show you the actual value. So I just know that in my previous code 1,000 worked, 1,000 A's buffer overflowed. If I put 100 or 800, who knows, it might work or not. In order to show you, let me do 500 and go ahead and exploit this. I'm going to show you just first 1 second. I just want to make sure that it shows it. I exploited it. It says done, and then nothing worked because at 500 the buffer doesn't overflow to the EIP register. It's just there in the RAM. It's just not flowing to the EIP register. But at 1,000 it somehow does. I don't want it to be a random 1,000, so I'm just going to go ahead and create a pattern of 1,000 unique keywords. Control C, and instead of my junk, I'm just gonna type let me just remove that real quick. That's it. Now it's unique. That means that if something gets overridden, I can actually find that value and reverse engineer that register to find that exact numerical value, which I can utilize to calculate where the EIP register is. So junk of all this meanings, how much junk do I need to put in before I reach the EIP value? That's basically what it is. So that's what I'm going to calculate. The next 4 after this is going to be the EIP registered. So save. I'm going to make sure that it's running. Everything is running. What is this? Hope it changes. Oh, this is from the 500 bytes which I sent earlier. As you can see, only 500 got copied. In our previous case, it was 1003. That means 3 extra bytes were moved on to like overflowing. So at 500, nothing works. I have to restart this for a quick second and then start again. Cool, it's running. Use our exploit in step 1. I'm just going to read you the same things again and again. This name, I need to change that. All right. Now what it's going to do is going to actually give me the exact value of my Eip register. Now you see that access violation executing this register value and it's paused. That means the program crashed. Where did it crash? This is the exact value. At this value, 357244134, the program crashed, and if I reverse engineer it in my actual thing over here, find the offset, it's asking for register value. So this is the register value. I just need to type that into my code over here, only if it works like this. So 357244134, finding an offset 357244134, and offset value will be, if I copy this, well, copies won't work. 357244134, it should give me an offset value of 524. Now here's what happened. If you were following this, we found the exact value after which the Eip register starts. So 525, 526, 527, 528 is the 4 bytes of the value where Eip is working. This is just how much junk I need to put in to go forward into my Eip register. I'm going to keep this in mind, 524, offset value of 524. Now, once that is set, I know that that's where the Eip starts. Just an FYI, 525, 526, 527, 528. You don't need to remember this, but in your brain, you should be actually crafting the exploit that I need to make sure that the next 4 is the Eip. But I don't know if that's going to be the same case. So what I'm going to do is I'm going to go ahead and remove this for a second. I'm going to type x41, which is A, times 524. That's my junk. That's how much stuff I need to put in. Now my Eip register is at, I'm going to try to put in as B. If I put 4 B's, and if it reflects on my Eip register as x41, x42, this is x42, which is B, capital B, 4 only. If this shows up as B, that means I've actually found the actual value for it. Now what I'm going to do, the next one is just regular buffer. It's just filler. You don't need to actually do this, but it's helpful if you know how to do it. 43, which is just C's. I'm going to put a value of, like, let's say 400. Just to make sure that I am actually reaching that value. So sorry, got my phone call. That's fine, buffers is fine. Now in my actual X payload, I'm going to type this as payload is junk plus, which is concatenation Eip plus buffers. Change that to payload. Now it's much easier to understand. What basically is, this goes first, overrides at number 4, at 4 values of B. The payload is just one new variable which I created to concatenate all this stuff together. And I'm gonna send that payload right over here to our exploit. Hopefully it works. I can close this. And it has paused. I'm gonna go ahead and restart. So far, I hope that you guys are understanding this. If you guys have any difficulties figuring things out, I am very happy to repeat myself, even though if I have to repeat the entire thing one more time. I just want you to learn this by the end of this session. That's my goal. And so that is done. Our exploit is created, and we need to make sure that we run it. I'm going to keep this open, save it. Python step, I really need to change the name. Yeah, okay. Now, few things are going to happen once I execute this, which is our step 2. We are going to make sure that our offset is correct. Second of all, we're going to make sure that our buffer exploit, our exploit is running fine. That's the 2 objectives which you want to make sure by the end of this exploit when we run it. So fingers crossed, everything is working fine here. And this is there too. I'm gonna bring this on the side. All right, so the program crashed. We can see clearly, as you can see, a bunch of A's junk, which we mentioned over here. A's will be the junk, 524 values. There will be 4 B's, which will be the EIP values, which I mentioned. There will be a 400 bunch of C's, which is just buffer. You don't need to worry about the C's. The only thing we need to worry about is the B's over here. We can also confirm that from our Eip register, which is showing as 42, 42, 42, 42, which is the actual value of B. And you can see a bunch of C's over here. There's A's. You can see it over here as well. A's follow, and then 42, 42 is just B's, and then the C's follow after that. That just means that we have successfully attacked our Eip register, and we can control it. Now it's the situation to figure out 2 things more. We need to make sure that our program is free from all the bad characters, and the second of all, we need to actually craft an actual exploit, which is going to be encoded in the buffer word. So what I'm talking is I'm going to show you over here before I confuse you a lot. So we have successfully overridden it. I'm going to go ahead and write my notes over here. Yep, offset is correct. Check. And our program is running fine. We can build up on that. Step 3. Step 3 is once we are done with it, we need to make sure that we actually find the bad characters. Bad characters are pretty straightforward. You need to make sure that you can find bad characters online available. It's pretty easy. I can show you. So our job with this is done. Now we move on to a new tool, bad characters generator. It was on Bulb Security's website earlier, but they kind of removed it. Bad character generator buffer. Come on, anyone providing me with bad characters? All right, this bro actually did an actual program which does the bad characters by default, so you can just copy this entire thing and paste it in our buffer. Now paste it like you see it, because if you miss out any colon or any commas or anything, inverted commas, it's gonna actually not run properly. Now, a few things to remember in bad character checking. whenever I run a bad character, I need to make sure that my null byte x00 is not available. I need to actually delete that. If I actually don't delete it, it's going to truncate the entire thing and the code will stop working. The bad character will be impossible to find. So I'm going to show you what it exactly means. Let's say you just copy pasted the bad characters and you want to make sure that you are going to remove my buffer, which was just C's, to bad chars. I don't need this requirement because that was what I was telling you guys. The buffer was bad characters going to be replaced by bad characters, and soon it's going to be replaced by your actual exploit. So we're trying to find which bad characters are breaking the exploit so we can remove them. Most easiest way to do that is just to copy paste the entire bad character, just like I did right now. Save it, prepare our Python, make sure that this is running. You can confirm you're not in the previous session by making sure that you see a new thread with ID so and so created. That means a new program has been running, new instance of it. Put this on the side, hit enter. What it's gonna do, it's gonna actually run the program the way you're supposed to be it, but it's going to make sure that EIP is working. What your main purpose for this program is to make sure that your bad characters are in order. So you can just do that by actually finding right click ESP. You right click on the ESP register and then you click on follow and dump. You can see all this gibberish. It's not in order. My bad characters were 01, 02, 03, 04 in order till 1F, and then 20, 40, 60. It's in order, human readable. But this is not human readable. Everything is everywhere. The only reason this happened was because of 00, which is the null byte. I'm gonna go ahead and remove that from my bad chars. Next, crash this, restart. Okay, play. This time, what I'm supposed to be expecting is that I see my hex dump in order of my bad chars. This will let me do an eye test to make sure that my bad chars are eliminated. I'll show you what I'm meaning by that. If I actually have this program is only vulnerable to 00 because they made it easy, but all your other buffer overflows will not be the same. Don't rely on that. If you don't do this step, your exploit will not work. Simple as that. Right. Run this. We know EIP is registered, overridden by BBBB. You right click on ESP register value, follow and dump. Now you can see that it's starting with 01, going till 0F, 1, 10, and then 11, 12, 13, all the way, and then it's going in order. Now here's where the tricky part comes. Your job to identify the bad chars is to make sure you do an eye test. You need to do this for the entire buffer. More than likely, it's gonna be a small thing like, okay, you have 01, 02, 03, 04, 05, then it's gonna be AA or DD or 00. But when you look at your actual bad chars, it was 06. So that link is broken. You need to identify that link. Which link was the reason why it broke? So in my case, after 05, if it becomes BB or CC or whatever it is, and then it's 07, I know that 06 value is the bad chars. I'm gonna go to my program. I'm gonna remove 06 from the program, from the bad char list. You do this until you reach FF, which is the end of the entire buffer. Kind of a pain, especially when you're looking at this, but you have to do this. I'll tell you why in a moment. So we know that our bad chars are working fine. I'm fine. The program is not allergic to any of the bad characters. I'm gonna restart this real quick. We're almost there, guys. We just have 2 more steps. We will find execution on our machine. So in recap, I created a junk which is going to be a filler. my EIP controller, which I know the exact value, which comes after 524. I'll put 4 more EIP values, and then I'm gonna put in the bad character values. This is important because the next step is going to be finding the jump ESP value. I'm going to show you what that is, and then second of all is going to be crafting an exploit. If whenever you're crafting an exploit, you need to make sure to mention which bad chars don't work in your program.exe, so that you can escape those bad chars and then run the actual exploit, which is going to definitely work. Without a doubt, it's going to work. So I know this, it works perfectly fine. In order to find the next is the jump ESP value. Now this value over here, you cannot just put it as 4 values. It's just not going to work. For that, you need to find the jump ESP value. I'm just going to close this, save it, close it. Okay, this job is done as well. I don't need that. By default, the jump ESP value is FFE4. Memorize it, write it down, tattoo it, whatever you want, but FFE4 is the jump ESP value. It basically jumps to the ESP register of your RAM. That's basically what it does. FFEF is standard in entire buffer. It doesn't change. The only thing changes is the location, but the FFEF value is going to be the same. How do I know it? I memorized it. Second of all, I can show you where to find it. If you go to CD, and if you go to ls, I think CD user share and then you have Metasploit framework. I've already done this before, so tools, and then you do this, and then you type, what is it? It should be in exploits, if I'm not mistaken, ls. Okay, so these are the bunch of Metasploit Ruby gems or Ruby exploits. From here, the only thing which we need to make sure is we check our nasm shell.ruby. So the most easiest way to do this is, it's already, if you see it in green, that means it's executable rights given. How do I know that? I see the X in the end of all these. Of our nasm shell, I see an X in the end. I can execute it by just using nasm shell. It's going to open the nasm editor where I can find the jump ESP. nasm just tells us where the actual value is and what actual value of the RAM you are controlling. So I am just going to type jump ESP FFEF E4. Like I said, tattoo it, write it down, memorize it, marry your significant other on that same date if you can figure out what that date is, and just memorize it. It's just helpful this way. Don't try to find this in the middle of exams. And once that is done, I know FFEF is the value. So what I'm gonna do is the string literal of FFEF in our exploit is going to be, I think I wrote it down in this one. Yeah. String literal is gonna be XFF XE4. That's basically it. If you're running this on your immunity debugger, you need to write it in this format. FF goes first and then E4 goes second. Once you're done with this, I am going to go ahead and show you what Mona modules are. Kind of important because Mona modules will actually show you how to get these kind of executables running, and second of all, where to find that DLL file or the exe file which is going to use that execution. So what you're trying to do is finding the jump address of that file, and you need to use Mona modules. You can do a simple Google search of Mona module buffer overflow, just 3-4 keywords, and you'll get a Python execution, Python file. A lot of people do this. I don't know why, but just go to any do stack buffer. So do stack buffer overflow is a cool Justin Stevens. This man literally made buffer overflow so easy to understand. If you got time, if you got energy, just do that entire thing. He has a PDF, you can just do that, or like your PDF and his entire do stack buffer overflow good one level program like brainpan.exe. Very helpful. After my session, just do this. You don't have to think twice about buffer overflow in any of the exams. This is sure shot given. After this, if you don't get it in the next 1 hour in your exam, you need to revisit certain things in the subject. So my Mona modules should be somewhere here. Where is Mona module? Yeah, I gotta dumb it down for Google. There we go. So this GitHub repository, this person modifies Mona like 8 months ago, so it's pretty latest. Literally 1,000 stars, so that means a lot of people trust it. All you have to do is download that entire GitHub repo. You should be knowing how to do this. You can use git clone, or you can just use download zip. Once you're done with that, open it up, extract it. You're gonna find it Mona modules master like this. All you have to do is copy Mona modules and paste it into a certain place. Immunity, I think immunity is in my x86 because it's that old. And then py commands, you paste it over here. I've already done it. It's gonna replace it, so I'm just gonna skip this file right now. But here are all the modules which are available for your stuff. Mona modules is right over here. Once you're done with that, you can use this small search box in the bottom. All you have to do is bang Mona, which is just exclamation for hackers. It's just what they do. Mona modules. Make sure that you're running this. If you are on paused, if it says paused over here, Mona module is not going to show you the correct response. Make sure it's running. Execution is right. My exe is working, and I press enter. Come on. There we go. So this is the module which you're looking for. It should only and only look like this. The key thing which you need to look at, that you are bypassing, bypassing all the ASLR and the OSDLL. These things needs to be bypassed. The only thing which can do that is showing false on all of these is brainpan.exe. So with brainpan, that's your program. That's your vulnerable program. Sometimes you'll see a DLL file. You need to make sure that you incorporate that DLL file. The only way to figure it out is to make sure that everything is false in your checks. If everything is false, you are good to go. Next up is I'm gonna type Mona find me the string xffxe4, which is, if you paid attention a few minutes ago, ffef is my ESP jump address. I want to know what is the ESP jump address for brainpan.exe. That's what we are using Mona modules for. For my module, brainpan.exe. Simple as that. Find me the ESP value for brainpan.exe. Press enter. Takes some time, but you'll see it in red. There we go. Found a total of 1 pointer. That's what you see. Sometimes you'll see found a total of 7 pointers. I found that in one of my exploits while doing buffer overflow, and literally it showed me 7 pointers, and it was so difficult to figure out which one it is. But the only way to find it, one of them will tell you ASLR is false, RBase is false, safe SEH is false, OS is false. These are all checks which Windows allows to make sure that your program is not a legit exploit. So Windows does this check for you. I found one. I need to write down this number which says 0x311712F3, which is my value. I need to write this down. Find the ESP jump address for brainpan.exe. I already showed you what Mona modules are, and I'm not going to type it over here. I'm just going to type the actual stuff. So which is your 311712F3. Okay, in order to write this in program format, I need to do reverse of this. It's called Indian notation. It's nothing related to people from my country. I don't even know if they invented this, but it's what they call this, Indian notation. You can Google search that. It's an actual thing. Indian notation is just reverse. So it's gonna be XFE and then F3 and then X12, which is showing up. It's just going in backwards, one thing at a time, two bytes at a time, and then it's gonna go X17, X31. That's it. That's the actual notation when you're writing this in your program, which I'm gonna show you right now, which is this. Now, instead of putting 4 BBBBs, which is X42, 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 I have put in the actual Eip register value for brainpan.exe. It will change for every single program which you debug, but for brainpan.exe, this is the ESP register value. I don't need this. This job is done. I'm gonna go ahead and do a restart on my program real quick. If you guys have any questions, shoot me in the message. Let's see if you guys have anything to worry about. I will answer that to my best of my abilities. I'm gonna remove this so it doesn't confuse folks. It's on paused. I don't want it paused. I want to run. Okay, it's running. BrainPan is running as well. Now, I found this ESP register value. How do I know it's accurate? How do I confirm that? In order to confirm that, I need to make sure I set a breakpoint in my program. Now, setting up a breakpoint just means that you want to stop the program from working at a certain point in the entire code. It's going to run through from top to bottom, but you want it to be ending at that exact place. In our place, that is 311712F3, which is the ESP register value. In order to find that, this is the break thing. If you can see it, it's the black one with an arrow and a straight bar. It's like this. So I'm going to click on that. I've already typed it, but I'm going to type it again, 311712F3. Click OK. It's going to highlight that. I'm going to double click on it to make sure that it's selecting the same. And if it does that, that means that it's going to break at this. If it highlights, then it's going to break the entire program at this value, and I'm going to make sure of that. How do I know that? Because the jump ESP value is FFE4, which we found it using our Ruby module, and that's written over here, jump ESP, JMP ESP. Now, all we have to do is execute our code with this EIP value, and we found this EIP value by finding the jump ESP value for this for brainpan.exe, which is this, and we wrote it in the reverse Indian notation. Once you put that in, first things is going to go is a junk, second is going to be the control EIP, third is just a shell code. If I run this, two things are going to happen. It's going to break at this point, and second of all, my EIP is going to be showing as this value, and I'm going to make sure to check this first because it needs to show this value because I've set that up. So save that. Gibberish. There we go. No, it's actually step 5. And don't worry about the program. I'm gonna write down all the programs in the template, so you can actually just watch the video and then follow up accordingly. Now let's pray that it works. Everything is running, double checks. I'm going to make sure that EIP is reflecting as this. So press enter, brainpan.exe. The program broke at this. You see that the highlight changed a little bit. How do I know that? Because this 311712F3 is showing up as this 3117 of 2F3, which is my Eip register, which I set up. Now I know that I am in control of the entire program. All I have to do at this moment is generate a shellcode, a reverse shellcode through Meterpreter. I'm going to show you how to do that. And you're going to appreciate why did we do the eyeball scanning of bad characters, which was the most difficult thing to do. So you're going to appreciate that later on. I'm going to go this, so just an FYI, brainpan.exe shows up at this value. Eip is showing up as 311712F3. You can see it over here, and I have in control. The jump ESP value has been highlighted as the program broke at that point. Clear that. Now also to make sure that the breakpoint at brainpan 311712F3 is showing up in the bottom as well. That's one way to confirm, but by this time you should already know that you are doing really well. Restart that program, play it again. Now I don't need to do this step on this. I can directly jump into my exploit development because what we did is find out if brainpan.exe can be vulnerable. We know that, we control the Eip register. All we have to do is create an exploit. So our debugging session is pretty much finished. We don't need Windows OS again. What we need is our actual brainpan.exe, brainpan, this virtual machine to be active. And we know the IP address. I've written down my sticky notes. It's 0.9. I can confirm that if I do netcat and nv lvp nv 172.16.229.9 9999. I see that brainpan.exe. That means I'm netcatting into that system and it's working. It's connected to that portal. It's bound to that shell, bound to that port. That means that I can execute it. Now my actual Python code is going to be slightly changing. But before that, I want to show you how to build an exploit right over here. And you can truncate all these steps to much more quicker the following way, but it's important that you know step by step how to reach this exploit step. But it's important. That's why I keep telling you buffer overflow is just a step game. If you know how to do the steps word by word, you will be actually much more comfortable doing this on a regular environment. So we're going to use Msf Venom. Msf Venom is a payload generator or exploit generator for Kali machines. Msf Venom is part of Metasploit, and it's supported by that. Every single exploit code can be generated from here. So what I'm going to do is Msf Venom -p Linux x86, because I know my code is x86. How did I find that? If I ran since I ran the nmap scan, it showed me that A, it's a Linux machine, second, it's an x86. So that way I can configure my exploit to be exploiting the Linux machine and giving me a reverse shell, which is the lhost -meterpreter reverse_tcp. This thing, reverse_tcp, all it does is gives you a reverse connection via TCP connection port. It's how it is. You just memorize it. Most people memorize this particular line. So we wrote Msf Venom payload. I want to generate this payload, lhost I want that to be my to be my wait, what is number 8? My Kali machine. So sorry, lhost is your local host, rhost is your remote host. Lhost stands for my machine where I want the shell to be coming through. Rhost stands for the machine where I want to push the exploit, and I want that machine to give me a reverse shell. Different analogy, but make sure that you type lhost as capital, and that's 172.16. Wait, that's not right. It needs to be equals 16.229.8. 8 stands for my Kali machine. L port will stand for any port which I define. I am going to spawn a reverse shell on my port 4444. So I'm going to put 4444 dash B for bad chars. Now you see that this is why we wanted to do this. Bad chars over here just make sure that when it tells Metasploit that hey, whenever you're doing an exploit for brainpan.exe, make sure you remove these bad chars, because from my previous reconnaissance knowledge I figured out that these bad chars are going to break the program. Hence, don't use it. Craft an exploit which doesn't utilize this. And I mentioned that it's just one bad char. In your future sessions is going to be multiple of them, so keep that in mind. And then format -f is going to be Python, because I wrote a Python code. It's going to generate a Shikata Genai encoding, which is just a fancy way of encoding Linux programs and exploits. You can see that x86 Shikata Genai succeeded in creating a size of 150 bytes as a total size of this much. Payload size, the final size of Python file is this much. Now, here's where most people fail in this exploit. They copy only till this much, because the payload is showing up gibberish until this much. What they forget is this top line. You have no idea. There were 2 times where I failed in creating a buffer overflow because there were some encoding where I forgot to do the top line because it doesn't show up properly. Like, there's nothing in this, so that's why it doesn't show up. But if you write this into your program without the top line, it's just gonna fail. So I'm gonna copy all this and I'm gonna paste it into my exploit code. I've already written that over here for safety time. Everything is the same except 2 new things I added. Nops, which is just Nop sled. What it does, Nops X90, what it does is that if the point, so here, let me just give you a background. Whenever you're running an exploit on a buffer, the buffer value keeps on changing. You want the buffer to be going wherever you're going and then coming back to the actual place, which is the Eip register, and it will keep changing. What Nops does, it prevents it from doing that. So basically, I have a Nops value of 15 for X90. Just do 1520. Don't think too much about this, just do 1520. It's just padding for your entire buffer exploit. I have copy pasted the entire buffer over here. It's word to word. It's literally copy paste from top to bottom, and it changes every single time. So this time, as you can see, what I did was earlier. Last one is X82, but last time I typed in was X3C, so it changed. What I'm gonna do is copy this. Don't reuse the same exploit again and again, as it's never gonna work. It keeps on changing. So paste that, bingo. In my buffer value, I've put in gibberish goes first, then goes my actual EIP address, then comes Nops, and then buff. Why did I do this? I could have typed junk. EIP value. Cool. Rest all looks fine. Buffer is been showing up over here. Now, few things are gonna be happening if I execute this. I'm gonna close this real quick. I'm gonna get a reverse shell. That's the first thing. And second of all, I'm going to get a complete reverse shell because I'm using Meterpreter. I'm going to show you how to use Meterpreter Listener. Meterpreter Listener is completely legal in your exam. Don't even think that it's not allowed. You can use it anytime you want. You cannot just use Metasploit. You can use Meterpreter Listener through Metasploit. Msf can't type console. This will launch Metasploit framework. That's a nice, whatever you guys call it, ASCII photo. Looks really neat. Yeah, okay, so all I have to do is use exploit, and if you use tab completion, it works in Metasploit, so you don't have to type everything. I'm going to use multi-handler, and I'm just typing tab, and it's going to complete everything for me. Multi-handler is just a way to catch Meterpreter reverse shells. As you can see, if it went through, it's going to show you a multi-handler in red. That means that you're using multi-handler. Now, what do you want to do with it? First, I want to set up my payload. Set payload to be Linux. If I type tab, it'll complete, yeah, x86, and then shell reverse TCP. Payload is completed. If you don't get any error message, you should be good to go. Show options. It's gonna show me that you need to enter the listening device, which you know by this time listening port is your Kali machine. I'm gonna do set lhost to be my 172.16.229.8. L port is the same. I don't need to worry about that, but if it doesn't pre-populate by itself, 4444 is your L port which you want to set up, because that's the exact thing which you set up in your exploit, which we did earlier. My Kali machine and my port 4444. Very important that you follow only one port the entire exploitation pen test, because if you mess that around, it's pretty hard to remember which one it is. Show options. Everything is pre-populated. All I have to do is exploit. Something is going to happen after this. I'm going to get a reverse shell from my brainpan vulnerable virtual machine, which I have created. This is the Linux machine, not the Windows one. That was just testing and debugging. So hopefully this works. Starting reverse shell. Okay, it's working. Now all I have to do is run my code. This is my code, and I'm gonna open up a terminal here, and it's gonna be exploit.py, so Python. All right, so I press enter. I'm going to see a reverse connection coming over here, so I just want to make sure that you guys see it and don't miss out on the important action. And press enter. Something broke. Line number 28. I think that was that junk stuff which I did. J is capital. Amateur. So everything is working fine. I forgot to do J capital, and then I want to make sure that this is showing. Enter. Session 1 opened on my Kali machine at port 444, coming from my Brainpan machine, which is at 9, the IP 9. In order to know if I am in it, you won't be able to see anything. Okay, I'll just do who am I. It shows Puck. I'm not Puck. My Windows machine is still Shubham. Puck is the one coming from there because I see that the IP address is 0.9. Now, in order to get an actual shell, Meterpreter has this cool thing called shell. If I enter this, it's gonna do a find bin bash and give me the actual shell like you see it on Linux. So there we go. Puck at brainpan, and then you are in that directory. Now if I do who am I, I'm still showing as puck in, or now is the time that you got low level shell. In order to do a higher level shell, all you have to do is run a bunch of scripts. There are two things which you can do. Now that you know you already have a low level user, you need to make sure that you run privilege escalation scripts. Now for extra knowledge basis, I'm going to show you Windows, oh no, linps, linps. This dude wrote linps.sh, literally the best Linux privilege escalation script. It's completely legal to do this. It's no problem in exams. It just gives you these kind of things. It tells you in and the GitHub actually tells you everything about it. I want to show you the color details. Yeah, red and yellow means that this is the only way to do privilege escalation. 99% sure. That's a confidence. So whenever you see linps and it gives you red and yellow, copy this thing and then paste it in Google. Most of the time you're gonna get GTFO bins for Linux. Copy that. Whenever you paste anything over here, you're gonna see that, okay, yeah, there is a problem with SUID. How do you privilege escalate that? So it's AWK is the issue. If you have actual non-interactive bind reverse shell, just use this and then configure this on your Meterpreter. And then GTFO bins actually tells you how these particular bins are actually infected and how you can actually exploit it. So pretty useful, but only once you run this. I already know how to do this. There's a second method to do this. Whenever you are in the new system, you do sudo L, and it's going to tell me what are the following commands which I can run as a sudo user. This is the first thing that you want to do in any of the lower level shell, because it tells you what programs are allowed to run. Now I know that whenever I ran this, it shows me that root access no password is provided to a utility thing called anasi_util. If I run this on anasi.util, you will if I run anything using sudo anasi.util, it's going to actually open up in root access. So that means that I can open up a nano or a vi shell, type bin bash, and then press enter to save it, and the moment I run it again, it's going to actually open up my bin bash shell as root. It's pretty simple. I'll show you. All I have to do is go to let me go back, cd nasi ls cd nasi anansi. It's not allowed. I'll use sudo. I can only use util as sudo, so I'm gonna go sudo home, which I'm already am, but I'm gonna go ahead and copy that entire thing. Nancy bin si_util. It tells me something whenever I ran that. It tells me that I can run manually any command, and it will give me the root privileges. Anything in the bracket action is the command which I need to put in. So if I type I need to type this one more time because somehow it doesn't support autocomplete. Util manual, and then when I want to type a command. And the most easiest way to do privilege escalation is to try to open up anything which can give you root access or terminal after the execution. If I run if I open up nano vi vim calculator in Windows as root, it's gonna give me a root access with which I can open up a terminal. Once you open up a terminal, you are golden. So all I'm gonna do is go ahead and open up Nano, because I know what Nano is, how to work on Nano. Press enter. Return. It's gonna give you a bunch of gibberish on what Nano is. You don't need this. This is just a man page. Manual page, Nano 1, line 1. That means you're in the first line of Nano. What do you want to do over here? All you have to do is type bin bash or bin sh, whatever, but bash works. Sorry, exclamation bin bash with forward slashes, and then press enter. It's gonna save that in that thing, and then it's gonna execute automatically. Because what I did was sudo whatever is in this program, run it with sudo access, and it's perfectly fine for me to do it because I did sudo -l. Now if you can see it, I have root access over here. I do who am I? I'm a root, so I own the stuff. And basically that's how you do privilege escalation. But our entire session for buffer overflow just ended, and I got root access to my program using buffer overflow. And if you want, I can answer any of your questions. But yeah, that's just buffer overflow for you folks. Please go ahead and go to any of the other sites of brainpan.exe 2 and 3 without using any of the walkthroughs. Do it by yourself. If you are successful in it, shoot me a message on Twitter or LinkedIn. I'll be more than happy cheering for you that you were able to complete it watching this video. So if you've got any questions, I'll be very happy to answer it right now. Just send it in the chat. But our buffer overflow session just ended. So yeah, congratulations. You sat through it. Thank you so much for the viewers. You sat through the 1 hour 44 minutes of a session. I'm so grateful that you guys donated your time to me, to watching the stream. And it just makes my heart melt to see that you guys are interested in what I'm doing and interested in this beautiful field of cybersecurity, and willing to give your time for it. So kudos to you guys, major props, and yeah, just let me know anything which you need on the chat, so I should be able to answer it. Thanks a lot, man. I try to be a decent teacher at least. But yeah, I'm glad that it makes sense to you. Buffer overflow is something which a lot of people skip because it's very intimidating. But I want to make sure that you guys know how to do this this type of exploitation. Rest of the things you can learn by itself. Buffer overflow has a huge learning curve. Hope you have a great rest of your day. You too, man. You too, Value Iron. Just send me a message on LinkedIn if you want to connect, so I can put faces to names. And just yeah, I would love to know what you're doing in your career as well, and anything which I can do to help you guys, just let me know. I'll do it for 3 more minutes. 5:40 Central Time. We should call it a day. Thanks a lot, Crazy Ass Scoop. Glad that you're watching this. You stayed up for the entire thing. Thanks a lot for doing that. Any more questions? I want to see if that Twitch thing is actually working or not. Oh yeah, that's working. That was pretty easy. Two more minutes, folks. I sent the Eip BOF to your LinkedIn. Yeah, dude, I'll check it out. Thanks for telling me that. I'm actually looking for a job in cybersecurity. Ironic, right? If you guys know anything as a SOC analyst, pen tester, please let me know. I'll be happy to contribute. Yeah. So. I do work in the field. I have my own side business, but at the moment I want much more stable income. the side business work whenever it's there. So I know red team job right now. Yeah, dude, just send me a message. I'll be very happy to join a red team. Bring in my knowledge. Pretty good at it, so good for an interview going on. So let me know. But yeah, the business works on the side. I try to donate as much time I can for contracts, um, but that's just external pen testing. But I would like to know how enterprises work. That's why I want an actual job as a pen tester in an industry, um, in a company, if that makes sense. Remote, I'll send you 2 job links for remote. My man, thank you so much. Much appreciated. Oh, I forgot to tell you guys something. I have a blog. I actually maintain that completely. Whatever new things which I'm doing, I actually write it over here. Um, you will see the buffer overflow steps right over here under red team. If you visit the blog, it's called cyber.shubhamkichi.com. Just visit it. It's amazing. It's a little bit about me in the about section, but there's a Raspberry Pi backdoor setup. It's the way I set this up is the most easiest way, step by step following. You don't need to have rocket science to know how to follow my blog, but it's very easy. I make sure that I use the fundamentals of my knowledge to explain how things work. So it's everything is step by step. So just take a look into it. That's where I post all my new walkthroughs. There's SQL injections. I was working on Port Swigger Academy, so there's a bunch of SOC labs. I was interested in SOC for some time, and connected with you yesterday. Thanks to Jason Blanchard. Looking forward to talking in the future. Jason Blanchard, I know him, but how did you connect from from his stream? If you know how he connected, just let me know. I'm more curious. Jason is pretty awesome. I've been talking to him since a long time. He just motivates me to get out there, do something which is uncommon and uncomfortable. So I like surrounding myself with people like that. Um, really cool guy. So yeah, I have experience in both SOC as well as Red Team. I don't like to pledge my allegiance to only one team, because you really don't want to be a specialty in one thing, and then an incident happens and they don't have too many smart SOC analysts, and then you happen to know a lot of SOC work. That's because you have interest in both the fields. So I like to expand my knowledge in both. I don't like to specialize in anything. I like to master both of them together. That's what I like to do. Like specialty is for insects. It's kind of stupid ass quote. I found it online. It's pretty famous quote actually. Specialty is for insects. Yeah, specialization for insects is it's a quote. A human being should be able to change a diaper, plan an invasion, butcher a hog, con a ship, design a building, write a sonnet, balance accounts, build a wall, set a bone. I don't even know how to set a bone, but comfort the dying, take orders, give orders, cooperate, act alone, solve equations, analyze new problems, pitch maneuver, program a computer, cook a tasty meal, fight efficiently, die gallantly. Specialization is for insects. Yeah, that's what I like to use for my life, so it helps. Oh, did he? He posted about your stream on LinkedIn. I attend a lot of Black Hill stuff. Oh, that's cool. Yeah, dude, I didn't know he posted that. It should be in my things. I think he liked it. Um, a lot of people liked it, but I don't know if he shared it, but most likely did. But I'm glad that you found me through that. I just love getting it, talking to people. This blog listed here. That is because I followed this Willow, my page. This is all in one thing. I like to follow this just gives me an entire oh sorry, that's not that's the wrong one. This is the correct one. I can edit anything over here. You just click on my website and it opens up my blog. I just like to set it up so people have all the places where they can get in touch with me, and my YouTube, Twitch, LinkedIn, Twitter, and my website. So found this from some Twitter handle, so it's much helpful. I don't have to give away every single thing. Just send one link and people follow that. What is it written in the website? Dude, it's this GitBooks. GitBooks is free. You can just create your own website. It's just darn easy. It's just like this. You just start writing. You don't have to edit like a ninja and know entire HTML and CSS nonsense. Just start writing, and then it has a bunch of things which you can set it up just like this, tables and what have you. The moment you hit save and merge, it's public. So make sure you write everything and then type it in, hit save and merge. It's going to be public for everyone to view it. So, and then I just used Namecheap to get my own domain, shubhamkichi.com, and then just make it much more official. So $2 investment. Get your own website. I think it's helpful. I think websites are important because your own personal blog is important in cybersecurity because people try to get to know better about you. I think I've found it a lot more beneficial that people want to know more about me, and I don't have anything to show, so I created something where they can follow me and know about my accomplishments. I was trying to make one with Hugo Golang. Dude, I want to learn Golang so bad because there's a lot of exploit I can write in Golang. And I want to kind of write a lot of exploit in Golang as well because it's much more quicker. But stuck trying to accomplish, aren't we all, man? Just trying to get something somewhere. But you got to put in the work. That's why it's important. Accomplish background. Oh yeah, the CSS, if you're wondering if that's what it is. CSS, JavaScript. They don't link. Okay. Dude, I don't know. I need to start dipping my toes in web development because I used to do a lot of web development freelancing for clients, and then I kind of stopped before I jumped into pen testing. I just got bored out of it. It's just the same thing, and it just keeps on iterating. Everybody's launching new technologies every day, so it's hard to keep up in web dev, but it's important to know how to do your stuff. Oh yeah, Markdown. Yeah. This is Markdown too. I can import it through. Yeah, if I'm in editor mode, I can import my my damn it, not getting the word. My Notion templates. Oh, okay, it does. Okay. Dude, like I said, I need to brush up my web dev skills. It's been a long time I set up websites for people, so I need to build my own. But I try to stick to the quickest and most easiest way to get up and get running. So, GitBooks is free. I worked it. I want each page to have a background image. I'll be interested in know what you come up with. Crazy ass Coop. You got it, man. I'm not that busy. Send me a message. All right, I think we are way past our time. I want to thank you so much for joining in. If this recording is available, which it should be, which it should not be because I forgot to hit record, but on my Twitter page, on my Twitch page, there is a recording, so you can just watch this entire thing the moment I finish the live stream. So you should be good. Anything else, send me a message. Very happy to talk to you guys. Until then, ciao.